We are going to study the supply and demand model. And the supply and demand model is intended to explain prices within a market where there are many buyers and sellers. So no single buyer and no single seller can manipulate the market price. There's no what we call monopoly power in the supply and demand model. Now, there are other models that do look at monopoly type situations, and those models are taught in principles of microeconomics. The supply and demand model is the best model for macroeconomics because in macroeconomic markets, we typically have many suppliers and many buyers. We will be getting to diagrams of the supply and demand model, but before we do that, we need to define a few terms, and one term is demand curve. A demand curve is actually the representation of a function, and that function shows the quantity demanded given a particular price. Quantity demanded is the quantity of units that buyers are willing and able to buy at that particular price. So let's look at an example. And a good example is to talk about the demand for oil. So for example, if there's a market price of $20 per barrel, quantity demanded according to this diagram tells us that 25 units will be demanded. Now, that 25 units could mean 25 million barrels. So if the market price, the world price of oil was $20, according to the information we have here, the world, all the buyers put together, would demand in total 25 million barrels. If the price is lower, if the price is $5, then that means a barrel of oil is a lot cheaper, and no surprise, the world demand, or quantity demanded, I should say, for oil increases, and it increases from 25 million to 50 million. If the price of oil went in the other direction, instead of being $20 a barrel, the price of oil was $55 a barrel, your natural intuition would be that quantity demanded would go down, fewer people would want to buy oil, and so maybe, according to this table, you'd have 5 million barrels demanded. Now, this sort of data can be used to construct a curve called the demand curve. So this diagram is the visual representation of the relationship between the price of oil per barrel and the quantity of oil demanded. And if the price of oil per barrel is $55 a barrel, you can read off the quantity demanded by following the dotted line to the right. It hits the demand curve there, it goes straight down to the number 5. So that's telling you that 5 million barrels will be demanded if the market price is $55 per barrel. Likewise, you can read off what happens if the market price is $20 a barrel. You read over to the line and down, demand will be 25 million barrels. And likewise, if the market price is 5, quantity demanded will be 50 million barrels of oil. Now, any point along that curve will tell you a similar fact about a relationship between some hypothetical price of oil per barrel and what will be the quantity of oil demanded. And you can see the inverse relationship between the market price. Quote a market price, we read off from this diagram what quantity of oil demanded will be. If you want to give it a math interpretation, It's like y equals f of x, where the y is the quantity demanded. The x is a market price, or a market price that has been quoted. Imagine that. And the f, the function, is actually described by that curve there. Now, strictly speaking, this diagram cannot be totally real world, because in the real world we don't have an infinite number of possible prices of oil per barrel. We draw the curve as a continuous line just to get the intuition correct, and also to allow us to use some math. So the example we just used is an example of reading horizontally. You quote me a price, I can tell you how much people are willing to buy. You could do it the opposite direction. You could say, okay, if I know that people are wanting to buy a certain quantity of oil, what price would they be willing to pay in order to obtain 25 million barrels, say? I could read that off the curve. So you can read horizontally and you can read vertically. So we like to say there is such a thing as the law of demand. And the law of demand is simply the idea that the demand curve is negatively sloped. Everything else equal. That's an important qualification. Everything else equal. If you quote a higher price for a product, we expect quantity demanded to decrease. If you quote a lower market price for a product, we expect quantity demanded to be higher. So that means the demand curve will be negatively sloped. And the logic for expecting this is we imagine that the buyers or consumers or purchasers are using a good and deciding how much to pay for that good, for a unit of that good, based on their own preferences and also the possibilities for substitution. That's like saying what alternative competing products are out there. So oil is a really good example. So if we talk about the demand curve for oil, that information, when tabulated and put in the form of the curve, is reflecting partly people's preferences for using oil directly or indirectly, and the existence and feasibility of alternatives to oil. So, for example, if we lived in a world where there was no other way to get energy except for oil, you would expect that the demand for oil would be relatively high, no matter what the price was. Even if the price was very high, we'd still have a very great demand for oil if it were the case there's no other source of energy. And the shape of the curve also represents preferences. So if people, everything else equal, prefer to be warm rather than cold, that will affect the shape of the demand curve. People will be willing to pay a relatively high price for oil because they like to be warm, they use it in heating, they like to drive, they like to fly, they have preferences to do things that require oil. So that law of demand is fundamentally assumed to be based on the behavior of buyers, and buyers' behavior is affected by their preferences and also by the existence or non-existence of alternatives to the product. Now we're going to get into a little more complicated and challenging area of the demand curve. And there are two concepts. One is the concept of consumer surplus, and the other is the concept of total consumer surplus. So what consumer surplus is about is like this. Let me give an example. Let's suppose that you were willing to pay $5 per gallon to buy oil. And maybe that's because you run a trucking company and you really need the oil to get the gasoline to run your fleet of trucks. So you are willing as an individual to pay $5 a gallon. But it may be that the demand and supply situation in the market is such that the market price happens to only be $3. So you, the consumer, individual, would have been willing to pay $5 for a gallon of gasoline. But because of market conditions, the market price is only $3. So you are, in a sense, better off. You're making a gain because you're paying only $3 for something that's actually worth $5 to you. We call that consumer surplus. It means like consumer gain. And the word surplus here actually originates from farming. A lot of terms in economics actually came about because of things 100 years or even 200 years ago. And 200 years ago, 100 years ago, even economies and people, a lot more of them were involved in agriculture. So for that reason, the word surplus came to be associated with the idea of gain or benefit. And so that's consumer surplus here. It means you're not being asked to pay your total willingness price. You are able to buy a good like oil for less than you would be willing to pay. That's consumer surplus. It's a net benefit to you, as we say. Now, if we take the demand curve and if we look at all the values that all the different buyers would put on purchasing a good, and there is a specific market price that's reigning at this particular point in time, if we add up all the consumers who are paying below what they would be willing to pay, that is total consumer surplus. And we're going to see that you can think of this as a geometric thing, an area beneath the demand curve and above the price. But I want to get the concept across first. Consumer surplus means you are paying less than you would be willing to pay because the market price happens to be relatively low for you. So here's an example with a hypothetical demand curve. And if we go with our curvy shaped demand curve, it sort of goes like this. If the price of oil per barrel was $80, look at the diagram on the left there. If the price of oil was $80 per barrel, then that means that the price of engine fuel will be very high. And the question is, who would be willing to pay such an outrageously high price for oil? Well, one person might be the president. The president flies Air Force One here, there, and everywhere, and the president doesn't care that much about the cost of jet fuel. So Air Force One, the president's entourage, the person who fuels, who gasses up Air Force One, is perfectly happy to pay $80 if need be for effectively a barrel of oil. Okay, so that's like, the rich person who's willing to pay a very high price for something. So that's on the extreme left of that curve, demand curve diagram on the left there. the $80, willingness to pay. And you see that green bar that goes from the $80 all the way down to 20. All right, what's that about? Well, in this example, we're going to assume that the market price for oil happens to be at $20 per gallon, or per barrel, sorry, per barrel. In this one, we're dealing with barrels, sorry. So $20 per barrel is the reigning market price. And don't worry about why it is, because we haven't done the supply side of this model yet. We haven't done the supply side, so you just have to take it as given, told you that the market price happens to be $20 a barrel. The president would be willing to pay $80 a barrel. Okay, or more precisely, the president would be willing to have the taxpayer pay $80 a barrel, but whatever. So imagine it's the president paying out of their own pocket. So the president would be willing to pay $80 a barrel. The market price is only 20. So that green bar there shows the net surplus, the net gain to the president at that point. The president would be willing to pay 80, but the president buys oil on the market and pays the market price, which is 20. So the president comes out a winner by $60 a barrel. That's what that green line means. The vertical distance of the green line is the difference between the willingness to pay price, which is 80, and the actual reigning market price, which is 20. So that's 60. And the horizontal distance, you can imagine that as being however many gallons the president would be buying at that market price of 20. Okay, so that total area of that green line is the net gain to the president, the net surplus, multiplied by the horizontal distance, which is the number of gallons purchased. And so the area of that rectangle, that really thin rectangle, is net benefit to the president. It takes account of the willingness to pay gap, and it also takes account on the horizontal of the number of units being purchased. Now let's go to Joe. And Joe is not the president. Joe is a regular person. And Joe is somebody who drives a lot for their own work and life. And Joe would be willing to pay a price that's maybe like $25. And Joe is willing to pay $25, but only has to pay 20. So that green vertical line is the distance between 20 and, let's imagine, 50 or 30, okay, whatever it is that Joe would be willing to pay. So Joe doesn't buy a lot of gas, so the horizontal distance of that little green bar for Joe, it's not a long horizontal distance, but it's got a vertical distance, it's got a horizontal distance, and whatever that green area is, that is Joe's total consumer surplus. Now, if we want to do some sort of mathematical exercise in calculating total consumer surplus, given the $80, well, actually the way it works is you go over to the right-hand diagram and we make a drastic simplification. We assume that the demand curve is not curved down. Let's assume it's just a straight line. This is to make the algebra easy. And as that line goes down, you can calculate the total consumer surplus, the total net gain for everybody in society by adding up all the green rectangles that you can imagine would exist. And those green rectangles would actually start with the highest one, the president's one, and then after the president there's maybe another green bar for the vice president. We don't show it on the diagram. Imagine a sequence of rectangles going from left to right. Their height is constantly decreasing. You pass by Joe on the way, and then you reach the point at which the willingness to pay is 20 and the market price is 20, and that's the point at which you've gotten all the consumer surplus for everybody in society. And look at the diagram on the right. If we want to calculate total consumer surplus, total gain for everyone in society by having a price of $20 per barrel, you do it by calculating the area of the rectangle. And the rectangle area is measured by taking half the base times height. Or you could say half of the height times the base, whichever way you do it. And it turns out that number happens to be 2,700 because of the way we've drawn it. So if you remember your geometry, you go from for the height, you go the distance from 80 to 20. So that gives you 60. So on the equation there you see 80 minus 20, that's 60. And the horizontal distance is 90. So that's where the 90 comes from. But to get the total area, you also have to do a division by 2 because this is a triangle. So the formula is half base times height, and the total amount of consumer surplus in society, given $20 is the market price for oil, it's $2,700. So it's about time that you all start doing a little bit of work and beyond listening to me. And so here's a simple algebraic question. What is total consumer surplus if the market price is 10? Okay, take some time. It's either $500, $700, or $1,400. And remember, half base times height. But the height is the difference between what the market price is and what people are willing to pay. Okay, I'm going to assume you've done your calculation, and here is the answer. The answer is $700. Why is it $700? Well, remember, the height in this case is 30 minus 10. And the quantity is 70, so the base is 70. So what you have is a base of 70 multiplied by the 30 minus 10, which is 20. So it's 70 by 20, which is 1,400. But remember, you have to divide by 2. So that gives you 700. Now, if you got a different number, there are a couple of reasons why, but I'll just point out one. If you calculated half base times height, and what you used for height was the $30, you looked from 30 down to 0 and you said, okay, that's the height. No, that's not the relevant height. The relevant height is not the distance from 30 to 0. The relevant height is the height from 30 to 10. Because remember, we're measuring net surplus, the gain over and above what you would be willing to pay, and you'd be willing to pay 10. So you start calculating the height from the $10 and then move on up to 30, and that's a distance of 20. So that's it. Okay, this is the last slide, and we're going to just do a quick description of things that shift demand, and we'll get more deeply into this next time. We've assumed that that demand curve is just there, and through every iteration until now, we've assumed the demand curve is constant. It doesn't move around. And we had a curvy version of the demand curve, and we had a straight line version of the demand curve, but either way, the demand curve never moved. And if that's all demand curves ever did, we really wouldn't have much to say about demand and supply, because we must be living in a static world where nothing changes. But of course, we do live in a world where things change. And so that demand curve does not have to remain fixed in position. It can move. and it is influenced by anything that affects the buyer's quantity demanded for the product. So, for example, think of a product like oil. If the income of the population generally goes up, everything else equal, we expect people to drive more and fly more, and that's going to tend to shift the demand curve to the right. In other words, if you quote me a market price, after the increase in income, people are more rich, they're going to demand a relatively high quantity. Another thing that can shift the demand curve to the right is population. If you have more people, everything else equal, quote me a market price, there's a lot more demand for the product just because there are more people. Another would be the price of substitutes. We talked about oil. If there are competing products to oil that compete for the position of supplying heat or fueling aircraft, we call those substitute goods. And what's going on with substitute goods can affect the demand curve. And I'm not going to explain any more than that. A price of a complement is the price of a good which is always associated with the good we're trying to buy. So I'm not going to explain any more than that. A complement is a good which is consumed at the same time as the product we're trying to analyze. Another factor that can shift that demand curve to the right or left is expectations. So for example, imagine we have a demand curve for oil and people think that somehow oil is going to become very rare soon because no one's allowed to drill it. We're predicting into the future. If we think in the future there's going to be like a shortage of oil, that will cause us to want to buy more oil today. So today's demand curve may be influenced by things that we think will happen in the future. That's what expectations means. And the number 6 thing is tastes. If the demand curve is the demand curve for oil and suddenly people decide they don't want to fly anymore, they just for whatever reason don't want to fly, we'd call that a change in taste. It's just like people have less desire to consume air travel. That will affect the demand curve. We will get more into these things later, and we'll also be talking about the supply side of the model. Everything till now, to sum up, everything now has been about the buyer behavior, the demand side. For this model to work, we have to also simultaneously look at the behavior of sellers, suppliers, and we will get to that.